let's quickly review what we did last day. So we talked about modern atomic theory, basically the stuff you learned in chemistry already. We got your protons, electrons, your neutrons. Your protons and neutrons are in the nucleus. Electrons are whizzing around outside. The electrons are the ones that move. And I'll give those of you that were awake, and I'll give you a chance to get caught up on this in a bit here. Atoms are electrically neutral, so the number of protons is equal to the number of electrons. That's something that you definitely should know. Oxygen is number 8 on the periodic table, which means it has 8 protons, 8 neutrons, and 8 electrons. So 8 positives, 8 negatives, neutral. 11 is sodium, Na, right? It has 11 protons, 11 electrons, neutral sodium atom. I'll review. Object can exist in 3 electrical states: neutral, positive, and negative. Neutral is when the protons and electrons are the same amount. Positive is when there's more positive particles than negative ones. Negative is when there's more negative. And you're going to have to sort of demonstrate that at the end of this period, that you know how to do that. And then we did the clicker thing, right?
Yeah, it was cool.
It was fun. Wait till I get your names associated.
We were supposed to do another map thing.
That was in your mind. And we did this, right? Okay. And I talked about protons are fixed in the nucleus. What does the word fixed mean there?
Permanent.
Permanent. They're stuck, glued in. Electrons are moving around. They're able to move. Okay. I think we left off here. Am I right?
Yeah.
Excellent. Okay. So, conductors. Not that guy. Right? Not that guy. Not Mr. Schmidt. Not Mr. Coombs. Different kind of thing, right? Tyler, you're going to put that away, right? You just nodded and said, but then you didn't. Do you have this out, Tyler? This little handout that I gave out? You should look for it. I gave you lots of time, like sort of, that was the point of that time period, so that you'd be ready to roll when I'm ready. So conductors are substances that allow electric charge to pass through them easily. Conductors have electrons that are not strongly held by their nuclei. Okay? So the nucleus of conductors is not able to hold onto its electrons. It's very weak. It's like the little kid you steal Halloween candy from. But you wouldn't do that, would you? You wouldn't do that. This allows the electrons to move easily along the conductor. Electrons are able to flow. And when you have electron flow, what do you think you got?
Electricity.
Electricity. Well done, Bunka. You've got an electric current. Excellent. So those of you that have this need to be filling in the blanks. Okay, so where it says conductors, right? Where it says conductors, you guys should have filled that in, right? You're looking. Allow me to demonstrate. You know the Lord of the Rings? One ring to rule them all? Well, this is the Lord of the Binders. 3 rings to rule all the papers. Little joke there.
Look at how organized you are.
Yeah? I might have to give out an organizational mark. There are some people that struggle with that. I struggle with it a little bit as well. Yeah, did you? Yeah? Glad to hear that. Well, it's true. I have some binders that are really organized. Like, look at this. Look at that. Isn't that awesome? I'm pretty proud of this. This is grade 9 science. Then there's things that I've taught forever, like grade 10 science, chemistry. I would fail the shape test.
Heart eyes.
Yes. Great call, Wet. Ask her about the flying pig. Flying pig. Okay, so you know about conductors. So here are some examples of conductors. Generally, all metals. Generally, all metals, right? What do they make like wires out of, Riley? Copper. Exactly. Copper wire. Very good conductor. Ions in water. Salty water will conduct electricity. The human body, as Tyler and his little gang of electric charge boys have discovered, that electricity will conduct through the human body. And if you stick a fork in a light socket, you'll also discover that as well. Please don't try that at home. Yeah, metals, ions, and water, human body. There's lots of things that conduct electricity. Don't you have a spot for examples? You got a spot there for examples, don't you? Okay. Okay. Insulators. Is that what I'm talking about?
No.
Someone's basement? Insulators or attic? No. I'm not talking about that. Insulators are substances that do not allow electric charge to pass through them easily. They do not. Insulators do not allow electric charge to pass through them easily. Insulators have electrons that are more strongly attracted to the nuclei of the atom. They're like that big tough kid hanging on to his Halloween candy. You ain't getting it from me. Okay? What's with you and Halloween candy? You don't like Halloween candy? Yeah. Urban myth.
No, it happened in Swan River.
Actually, I did hear about that.
It happened in Swan River.
Why would people do that?
I don't know,
I guess, so insulators are tough with their electrons. They do not allow their electrons to flow easily. They're like the mean old sisters there in Cinderella. They make her stay home. You know, electrons are unable to flow. They do not want their electrons leaving. They're like a dad that's grounded his kid. Examples are glass, plastic, water, air. Some of you may have seen these.
Yeah, what is that?
That's an insulator. It's like a glass thing. These are old. They sit on the top of hydro poles, right? They make sure that the electricity doesn't jump from the wire to the post. It might start a fire. Some of you might have seen this if you live near where some people have a ranch with cows. What would that be? What kind of fence would this be? Yeah, electric fence. And so that little plastic thing there is, again...
Do you have any copper wires here?
I might.
Can you tie copper wire to that thing, crank it, and everybody gets around holding?
Great idea.
Yeah.
Jessica, right?
Those fencing insulators do work.
Yeah.
They do help provide charge.
Oh, tell me about it, boy.
That's why you don't do
Okay, yeah, so yeah, don't do that. That's because there's ions in your urine which will conduct electricity.
And
I told you, we're only people holding hands and walking around. That's what the fence.
Yeah. Okay, so Jessica, what are you saying about the insulators?
Those do help provide a charge. Those amp it up to 2 volts.
If you touch one of those?
No, like for fence.
Yeah?
When you put them on the fence and then you run your wire through and plug the wire in or whatever, those amp up your voltage.
They increase it.
Yeah.
Oh, didn't know that.
You just have to get the ones from Sammy's and Abbott's.
Okay, so they don't really insulate, they actually they increase. Really? I'll have to check into that. Didn't know that. Okay. You can charge an object by friction. I showed you this the other day, right?
No.
You can charge an object by friction. An insulator can be charged. An insulator like plastic, Tyler,
Yeah.
plastic is an insulator, can be charged by rubbing it with the Amy Farrah Fowler sweater, right? Because this action can cause electrons to either be pulled off or deposited onto the insulator. So either when I do this, Tyler, I'm either putting electrons onto the plastic or I'm
Scooping them off.
scooping them off, depending on which one has the greater electron affinity. Which one wants to hang on to its Halloween candy more? Okay? Because the electrons are unable to flow, the transferred electrons will stay where they are placed. Okay, so one of these objects has a lower electron affinity, and we're transferring here. So here we've got, well, that's glass and silk. Well, I've got plastic and wool. Okay, so if you've got a glass rod and silk, which I think I do have in there, I'm not sure.
You should get that one instead. It's probably worth it.
Okay, if you've got glass rod and silk, where do the electrons go? Can you tell? Do you have that picture?
No.
You don't have that picture, right?
No, Bob.
Okay, can you kind of draw that, do you think?
No.
Can you
On
draw?
that next page.
Oh, it's on the next page.
Yeah.
Okay, so what do you have there on the next page?
No.
Oh, okay, yeah, no, don't draw on that one. We'll get to that one. Draw this one in there where it says charging by friction. Have you got a spot where you could draw it? Charging by friction. Yeah, you got a spot there, right?
Works to get that whole picture.
Okay, so yeah, draw your best. Show a silk cloth, label this, glass rod, and then we're going to talk about which way the electrons go. Okay, so here we've got a glass rod, we've got a silk cloth. Over here, I don't know if you can make that out or not, but these are, what charge is on these? These are positives. And these ones are negative. So which way have the electrons gone? Which way have the electrons gone? Because this is a negative charge, this means it's got, this one over here has more electrons, this one's got less electrons, so which way have the electrons gone?
It went off.
They've gone that way, they've gone to the cloth. So which one is stronger?
Cloth.
The cloth. The cloth is pulling off the electrons. Right? And then one of them becomes charged. And then because it's charged, it will pick up stuff. Just like that, right?
New way to transfer paper shreds.
Yeah. Not very effective. Not very efficient. Okay. So this transfer of electrons is determined by, big word alert, electron affinity. Electron affinity of the insulator. When two insulators are rubbed together, the insulator with the highest electron affinity, the bigger kid with the most Halloween candy, will take electrons from the other insulator and will become negative. So the one that's stronger, the one that has the higher electron affinity, will become stronger and exhibit a negative charge. The insulator that loses electrons becomes positive. I'm going to cut and paste this picture right there. Okay? So, which way did the electrons go again? The insulator that loses electrons becomes positive. Electrons go this way. When you lose electrons, you become positive. Question number 1, you've got it right there. You're going to have to read these and think. Why is the glass rod positively charged when rubbed with silk?
Mr. Bennett,
Yeah.
on the clickers it's saying X1 grade
Yeah,
0
because you went back and...
Oh, okay. Yeah, that's okay.
No, it's not. It doesn't work.
Now you can start. Are you good?
Yeah.
Okay, so now you can answer this one here. Why is the glass rod positively charged when rubbed with silk? Is it because, and don't just answer wild, random, read carefully. Glass is weaker, let its electrons go to the silk. Glass is stronger, let its electrons go to the silk. Glass is weaker, let its protons go to the silk. Glass is stronger, let its protons go to the silk.
It's not B because there's no silk, it's just go to the, on our paper.
Well, there's the correct question right there.
Okay.
So think about it carefully before you answer.
Mr. Bennett.
Correct answer is A. Let's investigate. First of all, how come C and D for sure are wrong? Protons. Do protons move? No. Okay, so which one is it going to be? Glass is weaker, glass is stronger. The electrons go to the silk, which means that the silk is strong, the glass is weaker.
Wait, you didn't look at something fast.
I don't have names yet. Okay,
No, you didn't look like the percentage of Google.
try the next one. Read carefully. Okay, correct answer is B. Let's investigate how you would do this. Why is the plastic rod negatively charged when rubbed with wool? So we've got plastic, and we've got wool, plastic. Plastic rod is negatively charged, which means it has extra electrons. Lane, are you watching? Did you get it right? Yeah? So the electrons go this way, so who's stronger? Plastic is strong, wool is weaker. Wool is weaker, let the electrons go to the plastic. B. Once again, protons, those two are out. Okay, so I'm going to give you this on the test. I'm going to give you this chart. Tyler, there was, I bet you over half the students last rotation looked at this and said, Mr. Bennett, I have no idea what this is talking about. Put a big star beside this. This will be on the test. I will give you two things. I will give you something like, oh, I don't know, cat's fur and cotton.
What does that mean?
And I will say, which one will be negative?
That's true.
Which one is the stronger? This is weak, this is strong. So the electrons go that way. Are you guys watching, Lane? You're not watching that. Adam, this question will be on the test. But you got to understand it, right? So the electrons are going to go from the fur to the cotton, and which one's going to be negatively charged? The cotton will have the negative charge, and the fur will have positive. If I went nickel with gold, same thing. Anything down this way, right? Stronger at the bottom, weaker at top. Pretty easy when you get it, right? Right, Tia? Am I good? Yeah? I've spoken English. I haven't given you the instructions in Spanish or something. You're going to return them right away. Oh, I was wrong.
He was wrong.
Oh, I was wrong.
Fail class.
He wasn't ready. Maybe he wasn't ready.
Try this one right here. Try this one right now. Do you have this one on your sheet or no? You do? Okay. Tyler, have you answered yet?
Yeah.
Okay. It's A, B, or C.
So when you program our games, we're gonna have like a sign.
A code that you punch in to make your name appear. Like a password. A PIN number.
And then it'll be like,
It'll say, waiting for Tyler Bunka.
okay.
I'm willing to switch mine to one
I just need to get those names typed in.
Code is 1, 2, 3, 4.
Waiting on 3 people. Press enter. When object A is rubbed with object B becomes negatively charged. What charge will object A have? This is pretty simple. If you don't get this, we're in trouble. Waiting on 2 people. Press enter.
Do so.
Come on, we gotta pick something. Yeah.
If object B becomes negatively charged, what will object A be? Correct answer is, did we get it all right? Oh. Correct answer is A. If object B is negative, this one must be positive. Here's a tip. When answering a question, you should always, before answering, read the question.
Like twice.
Always a big step.
Yeah.
Last one. Which object has greater electron affinity? We'll go back to the chart. Actually, you don't even need to do that. Which one has greater electron affinity? Think about it. Think about it. So, 3-point approach for the particle model. You need to understand all 3, Tyler. So, the word or concept here is the particle model, and the definition of it is that electricity exists because of atoms. If they gain electrons, they become negative. If they lose electrons, they become positive. That's what you got to know. Okay? That's all there is to it.
And you're giving us time to work on it.
I'm going to give you time to work on the history thing.
We don't have it.
You do. It's on the back side of that sheet. It's on the back side of the sheet that you were just writing on. It's on the back side of the sheet that you were just writing on, honey. So why are you not saying, Mr. Bennett, I don't have that 3-point approach? You have it. It's got to be in there somewhere.
That's the wrong thing, but yellow, what's your favorite color? Do it. Do it. Let me yellow, what's your favorite color? Do it.
Hello?
Yeah.
I do.
Oh,
Sure.
Talia.
Talia, the office is looking for it. Okay.
I'm trying to get that.
Here's a bonus thought of the day. I'm not giving you the answers until Friday. If friction causes static electricity, which we've already seen, how come there's no charge when you rub your hands together?
It's the same kind of product.
I think Riley may have it. Maybe I don't need to answer it on Friday. Hang on to that thought. The rest of you think about it. Don't say anything, Riley. Let them think. How come when you rub your hands together, we don't get static?
They're both negative. They're both positive.
Same material. Where would they be on the electron affinity chart?
Then
In hands.
in the same thing.
Right there, right? Like who knows where, doesn't really matter. It would be
Cats. Or
human hand and human hand. When you rub together, they have the same electron affinity.
if you rub your head and your hair together, that makes.
It creates heat.
So number 1,
I wonder if you possibly.
same electron affinity. Okay, now, last bonus thought of the day. When you put your wash in the dryer, it jumbles all around, you pull everything out, there's that yucky static cling, right? What do you put in your dryer so you don't get static cling, Lane?
Bounce sheet.
Lane, what do you put in your dryer so that you don't get static cling? The bounce sheet. So what's going on with the bounce sheet?
It's a whole lot of negative charges.
I'm going to answer that question Friday. I want you to think about that. Okay. The remainder of this period Okay, Lane, listen, I'm telling you the instructions for the remainder of this period. Ladies, those phones are mine. I'm coming back there right away, I'm gonna take them. Okay, that's fine, but you know what, Mom needs, you need to say right now, Mom, I just lost my phone because you're texting me in class. Okay? Moms and dads need to remember too that you're in class. Okay? On the back side, Tyler, I'm giving you the instructions for the next 10 to 15 minutes in class. You are to work on this. Yes, I know, you're done. Some people are done. Remember, it can be either a poster, PowerPoint, Prezi, video, interpretive dance, song, haiku, I don't care, as long as all of those things are covered. All of them. You have to cover the ancient Greek knowledge, the Dufay model, the Ben Franklin model, and the particle model, and you have to tell me why the model has changed over time.
Coach, can we have a partner?
No, on your own. The laptops are there, lots of smartly gotten one already. This is your time to work on it. Does everyone know what they should be doing? You can use your phone, yes. Now you can use your phone.
I'm not gonna be here on Friday, so if there's gonna be any